Ma'am, am I audible?
Yes, good evening, children. Good evening to all.
Good evening, ma'am.
Good evening.
Good evening, ma'am.
Good evening, बच्चे. Okay, so let's discuss something first. Okay, discussing about the numbers. See, everything began with natural numbers, right? Okay, then when we move away from natural numbers, then we include zero in it. We get whole numbers. Then we get integers. When we include negative numbers, we get integers, right? And जब हमारा काम integers से नहीं बनता, then what do we have? What sort of numbers we have? Some different types of numbers that are in between those numbers. So that's rational numbers. Okay, everybody knows this. This is all that you have studied previously in your junior classes also. Okay, and we have some other set of numbers, that is irrational numbers. But forget about that now. Here in this chapter, you will be studying only of rational numbers. Okay. Now, as you know, rational numbers, what are rational numbers? Rational numbers are those numbers which are in the form of P by Q, and Q is not equal to 0. And P and Q are integers, right? Okay. Right, children?
Yes, ma'am.
Numbers in the form of P by Q, where P and Q are integers and Q is not equal to 0. Q cannot be equal to 0. Okay, then if the denominator is 0, then the rational number becomes undefined. Okay. And apart from this, what do you have in rational numbers? How is it different from fractions? In fractions, we say fractions are also in the form of P by Q. But only difference is that P and Q over there in fractions are natural numbers. But in case of rational numbers, P and Q are integers. That means P and Q can take the values of 0 also and negative numbers also, right? But in case of fractions, it is only natural numbers. Neither 0 is there nor negative integers are there, right? And Q in any case can never be 0, right? So Q has to be non-zero. Okay, and we will be doing with the properties also of rational numbers. Okay, what different sort of properties are there? When we talk about closure property says that when we add two rational numbers, the answer should also be a rational number, right? This is what we studied. We studied over commutativity also. What does the commutative property tells us? Commutativity tells us that addition is commutative if we add two integers in any order. The the sum remains the same. The answer is the same. Okay. This is what we know. And when we talk about over subtraction, commutative property over subtraction, then we say that A minus B, if we have two integers A minus B, then A minus B is not equal to B minus A. Okay. Right? Are you getting me, children? So this is, yes, please either show thumbs up or you can unmute and say yes. Right. Okay, and for multiplication is commutative. That means if we have any integer, any rational number a multiplied with another rational number b, we can say that a multiplied by b is equal to b multiplied by a. The product is the same. Okay. And in case of division, we say division is not commutative. Why we say that the division is not commutative? If I say any rational number a divided by another rational number b, I say it's not equal to b divided by a. A divided by b is not equal to b divided by a. Why? Because in some cases it can be a rational number, but otherwise, what happens if the denominator becomes zero? If in case the denominator is zero, then it will be undefined. Okay. Okay. And even you can try for integer, even for rational numbers also. Okay. In some cases it may be correct, but otherwise it's not correct. So we have seen with examples also. Next is associative property for rational numbers. In associativity, we take three rational numbers, A, B, and C. And it says that A plus B plus C is equal to A plus B plus C. We have A plus B inside the group and C outside. Okay. And if we change the order of the group, then it becomes A plus B plus C. So subtraction is not associative because A minus B minus C is not equal to A minus B minus C, right? I hope you are understanding. This is all you know. This is nothing new. Okay. Just a second. Okay. Now coming to multiplication of associativity over multiplication. Let's A multiplied by B multiplied by C is equal to A multiplied by B multiplied by C. So that holds true. But this is not the case, case is not the same in case of division. Okay, associative property does not hold for, division does not hold in case of rational numbers. Okay, associative property. Right, children? Any doubt?
Ma'am, are you showing anything on the screen, ma'am?
Yes, I'll show you better. This is nothing new. I'm just discussing what you have done previously.
No, I'm just asking if you're showing anything, start coming anything on screen.
Okay, okay. If I show you on the screen, then we'll have to take some examples and do it again. Okay. Okay, so this is your chapter, right? We have been studying these properties. These are the properties of whole numbers, integers, right? This is just the recap, which you have done in your class 7th also. I hope you remember that. How many remember that in your class 7 also you have done this?
Ma'am, me, ma'am.
No one else? Charan Tej also remembers. Okay?
Yes.
Great. You can put on your video, Charan Tej. Rahim, you can also put on your video. Please put on the videos. Where is Rahim?
Ma'am, is it on?
No, Bichi, it's not on.
Now I think there's some problem. I turned it on.
Okay. Now we were discussing about the subtraction of rational numbers. So you can see here, this is the case of associativity. In associativity over addition first. Okay, you can see when three rational numbers are added. Associativity is how when you have a plus b added like this, a plus b plus c, and you have a plus b like this. This is how is your associativity over addition. And in case of subtraction, you have a minus b minus c, a minus b minus c. So when we are doing for addition, we have two rational numbers added with another rational number. Then when you solve it, what do you observe here? Are the two rationals equal? Are the two sums equal? So we find that addition is associative for rational numbers. That is, for any three rational numbers, the left-hand side is equal to right-hand side. That means associativity proves true in case of addition. Right? Are you understanding, Klasya, now? Okay, now in case of subtraction, what do we have? We have three rational numbers and there's negative sign here. We are doing over associativity over subtraction. Right? Okay, so subtraction, we say subtraction is not associative for rational numbers. If we have to prove this, how it is not associative for rational numbers, we will have to check out this. So first we solve this bracket. What do we get inside? We have here the LCM 10. Then you have minus 8, then minus 5. So this is inside the bracket. We'll just check out whether the left-hand side is equal to right-hand side. Right? And outside you have minus 2 by 3 and minus. Okay, so this first we are doing the left-hand side. So this becomes minus 2 by 3 minus, and this becomes minus 13 by 10. So when you again solve it, what do you get? 30 here. And then you have minus 20 minus minus 30. So you get plus, this is 43. Okay, so try the right hand side also. Try yourself.
Ma'am,
Yes.
ma'am, you did minus. Ma'am, you
Hmm?
did minus 20. No,
What happened? Yes. What happened? Say it loudly.
ma'am,
Hmm.
minus 20 subtracted to minus 13 will become minus 33. No, ma'am.
Minus 30. Okay, this is 33. Okay, good, bache. Okay.
Okay, ma'am.
So how about right hand side? What is the right hand side coming? Is it coming equal or not equal? Just check. We just have to verify. We know it is not equal because it's written here, not associative. Subtraction is not associative for rational numbers. We just have to prove. Okay, just by taking some example. Why Muhammad is not doing OSC? I told you to do the right hand side. See, this is nothing new. We have been doing this from our junior classes. So that's why I'm just taking it quickly. Okay. Hurry up. इतना time नहीं लगाते. So just take the LCM and do fast. First solve the inside part of the inside bracket. So got your value for right hand side? Hurry up, children. Anyone who can give me the answer? What did you get for the right hand side? Ronit? Yes, Ronit, give your answer. What do you get in the right hand side? Better solve the brackets first. Like this. See, inside the bracket in the right hand side, you are given this. Everyone, please pay attention if you're finding difficulty in doing this. See, you have this rational number. This is just as you add the fractions. This is just like that. Only thing is the negative sign here. See, when we are studying integers, I have already told you. When you study integers, you already know. Integers आपने class 7 में पढ़ा है, first chapter. Right? When we have same signs, then our answer also is also positive. When we have same signs, the answer is always positive. When we have different signs, the answer comes in negative. Okay? This much you know. Everyone knows this. So here when you have two signs together, then what do we do? Minus into minus becomes
Plus, ma'am.
so minus into minus, this property applies here. Sign rule. So minus into minus becomes plus.
Ma'am,
Yes.
I got the right hand side. I got the right hand side as minus 13 by 10.
Minus 13 by 10. So that means it's not equal. Okay.
And left hand side as 22 by 15. So these two are not equal, no, ma'am.
22 by, how did you get 22 by 15? That will be 11. Even if you reduce it to simpler form, if you divide this by 3, minus 11 and 10. Minus 11 by 10 हो जाएगा ना ये? This was minus 33 by 30. Isn't that? So this will become minus 11 by 10. So in any case, these are not equal. This is what we had to prove. Okay, we were already given that they are not, it's not associative. Associative nahi hai, that means they are not equal. Agar equal hota to associative hota. Okay, so this is not equal. We just had to verify it. Right? Okay. Okay, now coming to multiplication part, let us check the associativity for multiplication. Now, associativity is multiplying three rational numbers in any order, in the same order like that as we were doing. Grouping of A and B first, and then multiplied with the third one. Then again, multiplying, keeping the first one out and grouping the other two like this. Okay. But this says that associative property holds true for multiplication of rational numbers. Okay, because when you multiply this, you get both right hand side, left hand side equal. If you want to try, you can try. Just multiply this and get your answer. When you multiply this, just multiply all the numerators and multiply all the denominators. 2 minus 6, 4, 2 minus 6, 4. Same combination of numbers is there. So you'll get the numerator same. Same combination of denominators is there. Okay, and you just have multiply signs. So your denominator will also be same. Got it? 3 7s is 21. 21 into 5 will be 10. 21 into 5, 5 is the 10. And this side it will be 2 4s are 8. 8 into 6 is 48. So minus 48. And same combination of numbers are here with the multiply sign. So you will get this side also equal. So this proves that it holds true. Multiplication holds true. Associativity holds true in case of multiplication of rational numbers. Right? Okay.
Yes, ma'am.
Now let's do on the division part. Okay, I'll show you this, the division part. Okay, let me take another page now. Okay, now see children, associative property for division. Now we were just checking for multiplication, we found that it holds true. Now see associative property for division. Suppose you take three rational numbers like this, A is this, B is this, and C is 3 by 5. Suppose you take like this, okay? Then how does the associative property A divided by B divided by C like this? Two numbers in any order, okay? When you group in any order like this, the answer should be same. This is what it says. So we just have to prove it now, okay? I'm not writing. Okay, chalo. So in this case, actually, I'll tell you, this is not equal. Associative property does not hold for division. I'm telling you this in advance. Now here we will prove it first. Okay, let's do. Now take this in place of A, write 1 by value of A. Then B, what is B? Minus 2 by 7 divided by 3 by 5. Chalo, let's do the left hand side first. So start doing. Please tell me the answer. You do now. I am also doing. You also do. Okay. We will check the answer.
Ma'am. Ma'am. Ma'am, I got left hand side as minus 21 by 50.
Yes.
Ma'am,
Yes.
I got left hand side as minus 21 by 50.
Okay. Your final answer is minus 21 by 50.
Yes, ma'am.
Who is this?
Pranav, ma'am.
Okay, Pranav. And what about others? Are all getting the same answer? Are all getting the same answer or some different answer? Okay, let me check. See, then how do we divide two rational numbers? We write rational first the rational number like this. So then we have minus 2 by 7 divided by 5 by 3. What do we get? We just take the reciprocal of the denominator part with multiply sign in between. This is what we do. Is it? Yes or no? So just
Yes, ma'am.
multiply this and then divide. See here, 1 by 5 divided by, now when you multiply this, this becomes minus 10 by 21. Okay. So when you have 1 by 5 divided by minus 10 by 21. What do you get? You take the reciprocal of the denominator. ये जो denominator है, this becomes the reciprocal. Okay. So this will be
Into minus 21.
like this. So that means this will be 21 by minus 50. Either you write 21 by minus 50 or minus 21 by minus 50. This is
Ma'am,
the whole of the fraction. Okay, so Pranav gave a correct answer. Right, children? So this was the left hand side. Now we have to prove the right hand side also. Okay, we just have to verify that it's not equal to. I have written a not equal to sign here. We just have to verify with this example. So in this case also you will write the values of A, B, C. Now in place of A you will write the value of A divided by B is minus 2 by 7. Then divided by C is 3 by 5. Okay. Like this. Okay. Now can you do? Charantej, I want to answer from you now. Tell me what do you get inside the bracket part?
Minus 35 by 30.
Minus 35 by 30.
ma'am, minus 7 by 6.
Ma'am, if we do in lowest form.
No, I am just asking about the inside the bracket part.
Ma'am, inside the bracket, ma'am, 1 by 5 into 7 by 2, 7 by minus 10 or minus 7 by 10.
So 7 by minus 10, or you can even say minus 7 by 10. That's correct. Now what do you do when you divide this by 3 by 5? What do you get?
Again take the reciprocal of the another fraction, ma'am.
Very nice.
Reciprocal.
So you take the reciprocal of the
5 by 3.
part. So that becomes, and the sign also change. When you take the reciprocal, the sign also converts to multiply. Right. Okay. So now 5 and 10 will cancel like this. So this becomes minus 7 by 2 3s is 6. So right hand side you get minus 7 by 6. And on your left hand side you have got minus 21 by 50. So that means they are not equal. Okay, they are not equal. I hope you have understood this. And this proves that the associativity over subtraction of rational numbers is not true. Okay. I
Yes,
hope you have
ma'am.
understood this. Children.
We can write even 7 minus 7 by 10 also, right, ma'am?
You can write minus 7 by 10 also. Whatever it is. See, in case of negative, no, even if the negative sign in the numerator or it is in the denominator, this holds for the whole of the rational number. Okay.
Yes, ma'am.
Okay. So that does not make any difference. Yes, Pranav, you are saying something. You have raised your hand.
Ma'am,
Yes.
till now we have discussed about lots of numbers, ma'am, like rational numbers, irrational numbers, fractional numbers, ma'am.
Yes, yes. This chapter is all about properties only, Ruchi.
Then integers, whole numbers, natural numbers also there, no, ma'am.
Yes.
Then I heard about another type of numbers called imaginary numbers, ma'am. What are those?
So that is not in your, that you will study when you reach class 11. Okay.
Okay.
So be patient till then. So that you will study when you reach class 11.
Okay,
Okay.
ma'am. Okay. Ma'am.
That's also very interesting. So keep your focus here. If you understand this nicely, you will understand imaginary numbers also nicely.
Okay, ma'am.
Okay. Okay, now moving to another property. This chapter is all about properties. Okay. Maximum of the properties, and we'll have few examples also. Okay, what's the time? Is the class time? It's very little time. We have time. Okay. Now distributive property for rational numbers. Right? Distributive property. Now, what is distributive property? This is like this. Distributive property is.
Ma'am, I know, ma'am.
What is it?
If we write 3 into 4 plus 2, 3 into, again 4 plus 2 in brackets, no ma'am, we can again simplify it as 3 into 4 plus 3 into 2, ma'am.
Very nice. That's correct. Okay. Good. So if you have three rational numbers like this, A multiplied by B plus C, this is over addition. We have addition sign here. So this is over distributive property over addition. A into B plus C is equal to A into B plus A into C. Okay. A into B first and then A into C. Okay. Like this. This is what the distributive property tells us. Okay, if you have some rational numbers multiplied in this order, it should be like this: A multiplied by B plus A into C. Now we'll see whether it holds for addition and what about in the case of subtraction. Okay. So it's saying that it holds true for addition. Okay, let's prove it. Let's take some integers, sorry, not integers, some rational numbers. A is 3 by 8. I'm just taking the numbers, then we will, in place of A, B, and C now, you will put these numbers and we'll check. Okay, so let's do for the left side first, A into B plus C. So we have A as 3 by 8 multiplied, then B is minus 2 by 5 plus 6 by 7, right? Okay, so this is 3 by 8 multiplied by, just add these. What do you have inside? Whenever you are doing, always solve the bracket first. Okay, whatever you have. BODMAS पढ़ा था ना, याद है in junior classes? BODMAS. So we always do the bracket first. Okay, बच्चे? Okay, so just solve the bracket part first. Let's do. So that's 35. So this becomes minus 14 plus 30. Yes, Varshit, what happened? So this becomes 16. Okay. By 35.
Ma'am, while writing in exam also, we should write that distributive properties, this
Yes.
A into B plus C.
Yes, in the exam, you know, how will you get question like for on properties? In exam, you will be asked here that you are given these three integers and prove that the distributive property, it holds true for distributive property over addition or over subtraction. Okay, like this you will be asked. So here I'm just taking an example like this from my side. There these numbers will be given to you and you have to put this in the property and verify. Okay. So when we do the
even that formula also, ma'am.
no formula you might not be given. You might not be given. Okay, you might be given also. You might not be given also. But you have to remember this. What is distributive property? Because distributive property is the same everywhere. Okay, it's just in case of addition we write plus. In case of subtraction we write subtraction. Okay, right?
My school, my teachers.
So there is no multiplication and division in this distributive property, because if we in place of addition we write multiply, now this becomes like this only. So this becomes actually associativity over multiplication. Okay. Okay. And even if we write divide here, so that becomes associativity over division. So it is over addition, subtraction, like this. Okay. Division also you have. We'll do that. Okay, so solve the inside part first. You will have such questions in when we do the exercise sums. Okay, what do you get here? 8 and 16 cancels. You get 6 by 33. Right? So this was your left hand side. So what do we do in our right hand side? We have A into B plus A into C. So our A is 3 by 8. You can see here A is 3 by 8, B is minus 2 by 5, minus 2 by 5 plus A into C is 6 by 7. So you can have minus 6 by 40 plus this is 18 by 56. Okay, so when you add them, what do you get? When you take the you can reduce it to lower form first. Okay, this is 6 and this is, you can reduce this with 2 3s is, and you have 20. Then you can do it with 2 9s are. Okay, nice. So this becomes minus 3 by 20 plus 9 by 28. Then just take the LCM of this 20 28. Take the LCM of 20 28. What do you get? Then 2 5 2 7. That means 4 5s are 20. 20 into 7 is 140. So you get 140 here, and here you have minus. This is minus 3. So you have here plus 9. This gives you 24. So आप इसको solve करेंगे, you will get your numerator to be 24. Okay. So you get 6 by 35. Okay. Right, children? Okay, so you can see the right hand side is equal to your left hand side. So this property holds true for addition. Okay. Okay, now I give you 3 rational numbers. You prove whether this property holds true in case of subtraction also or not. Okay, just write down in your notebook. Multiply over subtraction. So just take down the numbers and you can try this. Try this and we'll discuss tomorrow, okay? Just try this, whether this holds. Write down the rational numbers now. Do it now only before you get up from your seat after the class. Finish this and then get up. Okay? This is the distributive property over subtraction, right? So you are given these integers, these rational numbers. You just have to verify this, whether it holds true or not. If it does not, then put an not equal to sign. If it does, then put an equal to sign. Okay? And prove these integers for one more thing. Okay, for division also do. A divided by B plus C. Okay, just check out if it holds true or not. So will you do this? Take this as a homework. Okay, children? Take this as a homework and I'll give you some more questions on your resource on the WISE app. Okay, more homework questions I'll give you on the WISE app. Right? But for now, you just note down this. These 3 integers, you have to prove these 2. Okay, these numbers are given to you, rational numbers are given. Note down correctly, A is equal to 3 by 8, B is equal to minus 2 by 5, and C is equal to 6 by 7. Okay? So, written everyone?
Yes,
I must end the class now. Have you all written this? Do it now. Okay, this is for your homework. Try this. This is for your homework, and I'll give you some more questions on the app also. Written, children, everyone? Anyone still writing? Anyone who's still writing?
No, ma'am.
Okay. Charan, done, bache? Charan Tej, have you written?
Done, ma'am. Done, ma'am.
Okay. So you must try this, take it for the homework. Okay. I'm ending the class now. And you can, after some time, you can check your homework in the Wise app also. Okay. Thank you, beta. Bye-bye.
Bye, ma'am.
Bye, ma'am.
Bye, ma'am.
Bye, beta. Bye-bye.
Thank you, ma'am. Ma'am.
Rahim, your video was not working throughout.
Yes, ma'am.
What happened?
Ma'am, I don't know. I tried, but it wasn't working.
Were you able to hear?
Yes, ma'am.
You were able to hear the class, no?
Yes, ma'am.
Okay. Chalo. See you tomorrow. We have a class tomorrow also. Bye, bache. Bye-bye.
Thank you, ma'am.
Bye. Bye-bye.
Bye.
Ma'am,
Yes.
when is our Vedic maths class, ma'am, next?
Your Vedic, just check your timetable.
Okay, ma'am.
Because for Vedic, you have a separate timetable, no? Check your
Okay,
timetable or just ask in the group. You must be having your Vedic class group, no? Just check, put a message there. So the teacher will answer you. When do you have? Put a message in the group, okay?
Okay, ma'am.
Yes. Bye.
Bye, ma'am.